Good evening students, today I am going to explain the implementation of AND function using the perceptron neural network for the bipolar inputs and the targets. So we will see the solution. So this is the track table for AND function. This is very popular, we know. Track table for AND function with bipolar inputs and the targets. It is containing the two inputs. This is x1 and x2 and this is the target. When the inputs are 1 and 1, then the output, this is target is 1. When the inputs are 1 and minus 1, the target is minus 1. When the inputs are minus 1 and 1, then the target is minus 1. When the inputs are minus 1 and minus 1, then the target is minus 1. And this is the perceptron network, or this is the architecture for this particular AND function. So here we are taking two inputs, x1 and x2. This is the input vector because it will contain multiple values of x1. That's why we are taking is capital X. This is capital X2. This will contain the value of all the x2s. And here we are taking, this is y's weight. This is w1. This is the weight between the x1 and the y. This is w. This is another weight. So these two weights and another weight. This is y's weight. Here we are taking the capital Y because it will also reflect the multiple outputs, and this is the actual output. This actual output can be found out by applying the activation function. This is activation function. This is activation function on the net input. When we will apply the activation function on the net input, then we will get 1 if the threshold is greater than 0. Here suppose we have taken the threshold as 0, so y is greater than 0, then it will be 1. It will be 0 when the y is equals to 0, and this is minus 1 when y is less than 0. We have supposed w1, w2 and v initially they are set to 0, theta is also 0. Now we will see the first input pattern, and the first input pattern is this we can see from the table. This is 1 1 1, this is x1, this is x2 and this is t. Now calculate the net input, that is y in, this y in will be b plus w1 x1 plus w2 x2. Now we will simply put the value of, this is y's weight, this is, we have taken this 0, this is 0 and this is also 0 and this is 1, x1 is 1 plus w2 is also 0, this is also 0. So this is 0 and this is 1 from here. It is equivalent to 0. So y equals to 0. Now we will calculate y, and this is, it can be obtained, y can be obtained by applying the activation function on this y. So if we apply on this is 0 when the threshold is 0, then the output this y will be 0. So it comes out to be 0. Now check whether this y equals to t or not. So we will check, this is y 0 and the target is 1. It means this is not equivalent. This is not equivalent, hence weight change is required because actual output is not equals to the target. That's why we need to change the weight. Now the general formula for change in weight, that is wi new, this is wi old plus alpha t xi. Here wi will depend on the inputs, number of inputs. This is new, this is old. This is learning rate parameter. Alpha is where? Alpha is learning rate. It is also 1. Here we are taking it as 1. It can be between 0.1 and 1. Now for W1 new, this is W1 old plus this is alpha t x1. W1 old is this is 0 and this is 1. This t target is also 1. This is also 1. So it is 1. So W1 new is 1. Now W2 new, in the same way we can calculate this W2 old plus alpha t x2. This is 0, this is 1, this is also 1. It also comes out to be this is 1. So W2 new is also 1. Now B, this is Y state, this is B old plus alpha t. B old is 0, alpha this one, this is 1, so this is also 1. So we can say that W1 is 1, W2 is also 1, and B, this is also 1. If we see the change in weight, then the change in weight will be, this is, it can be easily calculated, 1 minus 0, this will be 1, and the change in weight 2, this will also be 1 minus 0, this will also be 1, and the change in bias weight, this will also be 1 minus 0, that will be 1. Now, this first input pattern is completed, and these are the final weights after the first input pattern. Now we will submit the second input pattern. So for the second input pattern, this is second input pattern. This is 1 minus 1 minus 1. So this is 1 minus 1 minus 1. Now calculate the net input for this second input pattern. Y will be equals to B plus W1 x1 plus W2 x2. So this will be, it can be calculated as this is B is now this is 1 and W1 is this is also 1, x1 is this is 1, W2 is 1, x2 is minus 1, so it will be 1 plus 1, 2 minus 1, so this is 1. Now we will find out the y after applying we will apply the activation function on this. So this is 1 and this is greater than 0, so it will be 1. So this y equals to, after applying the activation function on this, we are getting the 1. Now we will check whether y is equals to t or not. From here also this y is not equals to the target, because this is 1 and this is minus 1, so this is unequal, hence weight change is required. Now we will calculate the new weight, and this is the general formula. This is general formula. Wi new equals to Wi old plus alpha t xi. Now W1 new will be equals to W1 old plus alpha t into x1, but the value of these are changed. So now W1 old is this is 1 and alpha is 1, t is now this is minus 1 and x1 is this is 1. So it will be equals to 1 minus 1. This is 0. Now it comes out to be 0. Now W2 new, W2 old plus W plus alpha t into x2. So we will put the value of this. W2 old is, this is 1, alpha is 1, t is, this is minus 1, and x2 is, this is also minus 1. So from here, this will be 2. So W2 is 2. Now B new, we will calculate the bias weight. This will be equals to B old plus alpha into t. And this B old is, this is, it can be written as, this B old is, this is 1, alpha is, this is 1, t is minus 1, 1 minus 1 will be 0. So in the second case, W1 equals to, this W1 equals to 0, W2 equals to 2, and B equals to, this is 0. This is these are the final weights after the second input pattern. So this is second input pattern. These two are completed. Now we will take the third input pattern. Third input pattern, and the third input is, this is minus 1, 1, minus 1. This is minus 1, 1 and minus 1. Now for the third input, we will calculate the net input. This is y equals to b plus w1 x1 plus w2 x2, and this is equivalent to, we can easily calculate. So this will be, now put the value of b, w1 x1 plus w2 x2, and the b is, this is 0. W1 is, this is also 0. X1 is, this is minus 1. W2 is 2. X2 is, this is 1. And it is equivalent to 2. Again we can see, this is B. B is 0. 0 plus W1. Now this W1, this is 0. And this is minus 1. W2 is 2, x2 is 1. So it comes out to be 2. Now in this case, because 2 is greater than 0, that's why the output will be 1 after applying the activation function. Now again we will check, this is output, and whether this is equivalent to target or not. This is not equivalent to target because this is 1 and this is minus 1. Hence weight change is required. So now again we will use the formula Wi new equals to Wi old plus alpha t xi, where alpha is learning rate, that is 1. Now W1 new equals to W1 old plus alpha t x1. So again we can find out W1 old is, this is 0, and alpha is, this is 1, target is, this is minus 1, and x1 is, this is minus 1. Now this will be 1. So this is 1. Now we can calculate the W2 new. W2 new is W2 old plus alpha t x2. WT old, this is 2. W2 old is 2. And this alpha is 1. Target is minus 1. X2 is, this is 1. So this will be 2 minus 1. This will be 1. Now W2 is 1. Now we will calculate the B new bias weight. this B old is, this is 0, this is 0, and this is alpha is 1, and T is, this is minus 1. It comes out to be minus 1. Now it can be written here. W1 is 1, W2 is, this is also 1, and B is, this is minus 1. So these are the final weights after the third input pattern. Now we will see the fourth input pattern. Fourth input is minus 1, minus 1, minus 1. So this is fourth input, this is fourth input pattern, and fourth input pattern is minus 1, minus 1, minus 1. Now calculate the net input, that is by n equals to b plus w1 x1 plus w2 x2. We can easily calculate by putting the values. So this b is, this is minus 1 now, w1 is, this is 1, x1 is minus 1, and w2 is, this is 1, x2 is minus 1. It will be, this is minus 1, minus 1, this is minus 2, minus 2, minus 1, this is minus 3, and minus 3 is, this is less than 0, that's why the output will be, this will be minus 1. Now see, this output is equivalent to the target here. So this is, output is equals to the target value. It means we have achieved the final weights. Hence, the weight change is not required. We will not calculate this. So after the fourth, W1 is, this is 1, W2 is 1, and B is, this is minus 1. So these are the final weights. Now we will see the table. We will go, this was the first epoch. In the first epoch we have submitted all the 4 input patterns. Now we will see the second epoch. In the second epoch again we will submit all these 4 input patterns, and then we will calculate the net input, and we will check whether the output is equivalent to target or not. So but ultimately we will get these final weights. So now we can see this by using the table. From table we will see. So now after submitting all the 4 inputs values, we have achieved some final weights. So this is the table for training of perceptron network. In this we have shown all the parameters that we have taken in this problem of AND function using the perceptron network. This is input. We have taken 2 inputs, x1 and x2. This is y is input. This by default, this it can be taken as constant. This is target value. This is t. This is net input. This is net input, and this is calculated output. This is why we will get this by after applying the function, activation function. These are the weight changes, change in weights. These are the weights that we have taken, like W1, W2, and this is y's weight. And in the starting, we have already shown that we have taken this 0, 0 and 0. Now we have submitted these 4 inputs. We have already submitted these 4 inputs, and we have seen that in this 4th input of epoch 1, this is epoch 1, this is epoch 2. In the 4th input of the first epoch, when we have submitted this pattern, this is x1, x2, 1. So the target is -1 and we will compare this target with calculated output. So the calculated output is equals to this target. So it means at this point we have achieved the final weights. These are the final weights 1, 1 and -1. Means the value of W1 is 1, value of W2 is, this is 1, this is B, this is also -1. So now we can also see the weight changes at this point when we have achieved the final weights, and this will be 0 because the difference will be 0. So this is 0, 0, 0, delta W1, W2 and delta V. So this was the calculated output -1, this was the target output. Now we can also submit, we can go for the Epoch 2. In Epoch 2 when we will submit these 4 input pattern, then again we will get the same weights. Means these are the final weights. At each input for the second epoch we are getting the same value. This is W1, W2 and this is bias rate. So in these 4 input patterns we are getting the same value. It means we can say these are the finalized weight. So in this table we have shown that we have achieved the our final weights, that is W1, W2 and B. Now on behalf of this we will see whether these we will draw a line that will be the straight line, that is the we will show the linear of separability condition, whether these weights are separating our negative and positive response. Now the final weights after second epoch, W1 is 1, W2 is, this is 1 and B is 1. So these are the final weights and bias. After the second epoch we have seen 2 epochs in the table, epoch 1 and epoch 2. So after second epoch we have found these weights and bias. Now the equation for the decision boundary of separating line, it can be given as this is B plus W1 x1 plus W2 x2 equals to 0 because theta is 0. Now put these values in this equation. So this will be, this is -1. So this is -1 plus 1 x1 plus 1 x2 equals to 0. This implies that -1 plus x1 plus x2 equals to 0 or x2 equals to minus x1 plus 1. So this is the equation for the decision boundary. Now we can take some coordinates to draw the straight line. So if x1 is 1, if x1 is 1 and x2 is, this will be -1 plus 1, this is 0, and if x1 is 2, then x2 is, this is -2 plus 1, this is 1. If this is 3, then x2 is -3 plus 1, this is -2, this is -1. So by using these coordinates we can draw the straight line. Now Now the decision boundary for AND function using perceptron. Decision boundary for AND function in perceptron model. So we can draw the straight line. Suppose this is x1, this is x2, this is minus x1, this is minus x2, 1, 2, 3, 4, 1, 2, 3, 4, that this is 1, 2, 3, 4, 1, 2, 3, 4. Now when x1 is 1, then this is 0, so this is 1, 0. It can be plotted here. When this is 2, then this is minus 1. So this will be, when this is 2, then this is minus 1. And when this is x1 is 3, then minus 2. So this will be here. Now we can draw a straight line. This is the straight line. In this straight line, we can see the input values were 1, 1. This was 1, minus 1. This is minus 1, 1. And this is minus 1, minus 1. For this, we were getting the positive response. This is positive response. This is negative response. And this is also negative response. This is also negative response. So see, it means we can say this straight line is separating the positive and negative response regions. So we can also show it. This is negative. This is negative region. This is also negative region. This is also negative region. And this is positive region. And this is the equation of the straight line or decision boundary. So at the conclusion, it is clear from above the straight line that straight line, it is clear from the above straight line that it separates positive and negative response regions. So we can easily see. So this is complete. This was the AND function using the perceptron model. So this straight line, this is the decision boundary for AND. In perceptron we can say using, or we can also say this in perceptron model. Thank you.